Well, so far we have discussed about the discrete random variable, which assumes only the countable number of values. However, the continuous random variable assumes an uncountable number of values in an line interval. In a line interval, the continuous random variables can take on an infinite number of possible values corresponding to every value in an interval. For example, we might have a random variable that takes on any value between 3 and 4, and our random variable might take on the value 3.1 or 3.12 or 3.1578 or any of the infinite number of values that comes between 3 and 4. So one common one or the common one that we can have a random variable that is taking on any positive value, so any value between 0 and the infinity. So talking about the continuous random variable, we cannot model the continuous random variables with the same method that we used for the discrete random variables. There will be some similarities, but we will have to use some different methods. So we model a continuous random variable with the curve. Here we can see in the figure this curve fx, which we call the probability distribution function pdf, and the values the random variable can take on are given down here. We can see here in the x-axis, the x-axis and the pdf. The x-axis contains the random variable that can take on the random variable that can take on the some certain value, and the pdf fx is a function giving the height of the curve at those values of x, and here fx represents the height of the curve at the point x. An important notion is that for continuous random variables, probabilities are the area under the curve. So we can see here, we can see some range like a and b, and here the probability is estimated in terms of the area under curve. So a continuous random variable is not defined at specific values like at x is equal to 3 or x is equal to 4. Instead, it depends on the over the interval of the values, like from the interval of a to b, and it is represented by the area under curve, and in advanced mathematics it is known as the integral. So what we do is this area under curve is obtained by the integral of functions. Suppose we have this fx function, and this x range from a to b, so we take the integral of function fx ranging from a to b. So the probability of the random variable x is exactly equal to any specific value is 0, as suppose if at point a is equal to 3, it's 0, and the number of values which may be assumed by the random variable is infinite. So now suppose a random variable x that takes all the values over the interval of real numbers a and b, then the probability that x is in the set of outcomes a, and this is like this pa, this is the probability that x is in this, then the pa is defined to be the area above a. We can see here, suppose if we have the set a that comes between the range of a and b, and the probability that lies between a and b will be the area above this line, and it's above a and under this curve, and the probability, the curve which represents the function fx, must satisfy the following requirements. Here are two requirements: that the curve fx has no negative values, that means fx should not be less than 0, it should be greater than or equal to 0 for all x, and the total area under the curve is equal to 0, or the integral over the values of random variable must be equal to 0, means this area under the curve which ranging from minus infinity to infinity is equal to 1. And a curve meeting these requirements are known as the density curve. There are a number of common continuous probability density functions that come frequently in theory and in practice. One commonly used probability distribution function is the normal distribution, like this one. This is the normal distribution, and this is extremely important continuous probability distribution function. And another one is the uniform distribution, which where fx is constant over a range of all possible values of x. We can see here this is the distribution function that ranges from a to b, and it is constant over the range of a and b. And another one is the exponential distribution functions, which looks like this. And these are the basics of continuous random variable and continuous distribution function. So next we'll be discussing about the normal distribution in more detail.